Hello and welcome back to another Algebra 1 video. Today we'll be covering lessons 2.4 to 2.5, which talk a little bit about the different methods of writing and graphing linear equations. We'll start with lesson 2.4, which is graphing equations in standard form. Let's first look at an introduction to standard form, which is represented by the following equation: ax plus by equals to c. Here's an example of an equation you might see in standard form: negative 2x plus 3y equals to negative 6, where the negative 2 is a, the 3 is b, and negative 6 is c. Now, if you were to plot this on a coordinate plane, whenever you're graphing with standard form, you're actually going to use your x-intercepts and your y-intercepts. So that would look like this. As you can see, it looks exactly the same as any linear equation that we graph, except today I'll be teaching you how to use the intercept shortcut when given a linear equation in standard form. Before we look at that, let's take a refresher on what the x-intercept and y-intercept are. Pretty simple. The x-intercept is where the line will intersect the x-axis, or the point where the line crosses the x-axis. And same goes for the y-intercept. It's the point where the line crosses the y-axis. Let's go ahead and look at graphing linear equations using the intercept shortcut. Now, this applies strictly to linear equations that are set in standard form. So make sure you're looking out for equations that are in ax plus by equals c form before you carry out this process. So to graph using intercepts, you have 4 basic steps. First, let x equal 0 to determine the y-intercept. Do the same for the x-intercept by letting y equal 0 for your second step. Third will be to plot both of those points. And then 4, connect them with a line. I'll go ahead and do an example so that you can better understand these steps. So we have an equation in standard form: 4x plus 3y equals 12. Number 1, we're going to let x equals 0 and determine the y-intercept. When we let x equals 0, that means that you just substitute x for 0. So plug in 0 for your x value. Notice how that when you do that, your 4x completely cancels, since any number times 0 will just equal 0, and you're left with 3y equals 12. Now you can actually divide both sides by 3. And once you do that, you get your y-intercept, which is just y equals 4. And once you've done that, you can go ahead and plot this value on the y-axis right there and plot your point. Now you can go ahead and do the same for your x-intercept. This time you're just going to let y equals 0 to determine the x-intercept. So do the same. You get 4x plus 3 times 0 equals 12. 3 times 0 will just equal to 0, so that cancels out. And you're left with 4x equals to 12. Now you can go ahead and isolate x by dividing both sides by 4. And now that you have your isolated x value, which is 3, you know that your x-intercept, or the point on your x-axis where the line will cross, will be 3. So go ahead and plot that. Now the minimum points you need for linear equations is 2. So now that you have your 2 points, you can go ahead and connect them with a line. Okay, let's go ahead and move on to another example. We have 2x plus 3y equals 12, and we're going to be using intercepts to graph them. This equation is in standard form, so I'll go ahead and use the intercept shortcut. For this example, I'll go ahead and use a chart so that I can organize our points. And our first step, we're going to plug in 0 for x. So if you do that, you plug in 2 times 0 plus 3y equals to 12. And then 2 times 0 will just cancel out to 0. So you're just left with 3y equals to 12. Divide both sides by 3 to isolate y. And you're given that y equals to 4. So your y-intercept would be 4. I'll go ahead and put that into our chart. Let's go ahead and do the same to find our x-intercept by substituting our y value for 0. So 2x plus 3 times 0 equals to 12. 3 times 0 just equals 0, so that cancels out. You're left with 2x equals to 12. Divide both sides by 2, and x will equal to 6. So your x-intercept will equal to 6. Now that you have both your x-intercept and your y-intercept, you can go ahead and plot these on your coordinate plane. I'll go ahead and first plot 0 and 4 right there on your y-axis. Then go ahead and plot 6, 0, which is your x-intercept, and that would be right there. Last step, just go ahead and connect your points to create your line. Okay, let's go ahead and look at another example. We have 5x minus 2y equals to 10. I'll go ahead and lay out my chart right there just so that we can organize our points. So first, I'll go ahead and substitute x for 0 to find my y-intercept. So 5 times 0 minus 2y equals to 10. 5 times 0 is just 0, so that cancels out. You're left with negative 2y equals to 10. Now you can go ahead and divide both sides by negative 2 to isolate y. And that gives you y equals to negative 5. So now that you found your y-intercept, you can go ahead and put it in your chart. I'll go ahead and now substitute our y value for 0 to find my x-intercept this time. So 5x minus 2 times 0 will equal to 10. Negative 2 times 0, make sure you're considering what sign is before, will just cancel out to 0, and you're left with 5x equals to 10. Divide both sides by 5, and you're left with x equals to 2. Go ahead and input that into my chart. And once you've done that, you can go ahead and plot both of your points. First, I'll go ahead and plot my y-intercept, which is 0, negative 5, and plot your x-intercept, which is 2, 0, and draw your line through those 2 points to create your line. And there's 5x minus 2y equals 10 plotted on your coordinate plane. Go ahead and pause the video to try this example. If you're feeling confused, no worries, we'll go ahead and go over it right now. So we have the equation x plus y equals negative 2, and we're using intercepts. So I'll just put my chart right here so that I can lay out our ordered pairs. First, go ahead and plug in 0 for x. So since there's no coefficient in front of our x and y, I can just plug it in. And then you get 0 plus y equals to negative 2. 0 can cancel out, and you'll notice here that you just get y equals negative 2. There aren't any additional steps to solve, so we can just put that our y-intercept is negative 2. Do the same to find your x-intercept by plugging in 0 for y. So that would give you x plus 0 equals to negative 2. Once again, 0 is just canceled out, and you're left with x equals negative 2. So your x-intercept also happens to be negative 2. You can go ahead and plot those. So I'll go ahead and first plot the y-intercept at negative 2, then the x-intercept at negative 2, and then connect my points with a line. Go ahead and try this next one. We're going to go ahead and graph negative 1/2 x plus 2y equals 6 using intercepts. So I'll go ahead and lay out my chart. We have 0 to plug in for our x value. So I'll go ahead and put 1/2 times 0, negative 1/2 times 0 plus 2y equals to 6. So first, cancel out your negative 1/2 times 0, since that just equals to 0, and you're left with 2y equals to 6. Divide both sides by 2 to get your y-intercept, and you're left with y equals to 3. So now that you found your y-intercept, do the same to find your x-intercept by setting y to 0. So you get negative 1/2 x plus 2 times 0 equals to 6. 2 times 0 cancels, and you're left with negative 1/2 x equals to 6. Recall that to cancel anything that is multiplied by a fraction, you just multiply both sides by the reciprocal. So that would be negative 2/1. Those cancel, and you're left with x equals to 6 times negative 2, which would just be x equals to negative 12. Now that you have both your x-intercept and your y-intercept, go ahead and plot them. I'll go ahead and go by 2's on this graph since it's a little bit small to plot negative 12. So go ahead and plot your y-intercept 0, 3, then your x-intercept negative 12, 0, then connect them with a line. Here's one last one for you to try on your own. You have 2x plus y equals 5. I'll go ahead and first substitute 0 for x to find my y-intercept. So 2 times 0 plus y equals to 5. 2 times 0 is just 0, so it cancels, and you're left with y equals to 5. No additional solving to do to find your y-intercept. So your y-intercept will just be 5. And then you can go ahead and do the same to find your x-intercept by substituting y for 0. So 2x plus 0 equals to 5. 0 cancels, and you're just left with 2x equals to 5. You can go ahead and divide both sides by 2. And you're left with x equals to 5/2, or as a decimal, it would be 2.5. Now that you have both your y-intercept and your x-intercept, you can go ahead and plot them on your coordinate plane. So go ahead and first plot 0, 5, and then you can go ahead and plot 2.5, 0, and then draw a line to connect both points, and there is your solution. Okay, let's go ahead and look at a word problem. So we're given that we have $6 to spend on apples and bananas. We're going to first graph the equation 1.5x plus 0.6y equals to 6, where x represents the number of pounds of apples and y represents the number of pounds of bananas. So my way to always approach word problems is to make sure to always keep in mind what concept you learned in that lesson. So let's go ahead and complete letter A first, which is to graph 1.5x plus 0.6y equals to 6. We can see here that the equation is actually in standard form, ax plus by equals to c, so that you can actually use your intercept shortcut to graph your line. So I'll go ahead and first lay out a table just to organize the points, and then we can go ahead and first plug in 0 for x to find my y-intercept. And that gives you that 1.5 times 0 will just equal 0, so that cancels out. Then you're left with 0.6y equals to 6, and 0.6 will divide to isolate y, 6 divided by 0.6 will just equal to 10. So your y-intercept will be 10. Now we're going to go ahead and do the same for our x-intercept by plugging in 0 for y. So 1.5 x plus 0.6 times 0 equals to 6. 0.6 times 0 will just equal to 0. So you're left with 1.5x equals to 6. Divide both sides by 1.5. 1.5 cancels and you're left with x equals to 4. So your x-intercept will equal to 4. Now that you have both your points, you can go ahead and plot them. I'm going to go by 2's on the graph. So this will be 2, 4, 6, 8, 10. And there's your y-intercept. And go ahead and plot 4, 0 on for your other point. And now that you have your 2 points, you can go ahead and connect them with a line. And now that you've completed letter A or part A of the question by graphing 1.5x plus 0.6y equals 6, you can go ahead and look at part B. So they're asking us to interpret the intercepts. Whenever you're asked to interpret anything on the graph, you're basically just stating what it means literally. So let's go ahead and break down our equation. We had x equaling the number of pounds of apples and y equaling the number of pounds of bananas. And we know that we originally had $6 to spend. And if you recall, our equation was actually set to 6. So after we graphed it, we had our x-intercept equaling to 4 and our y-intercept equals to 10. We're going to go ahead and interpret these two values. So basically with $6, which was the value that our equation was set to, we're able to purchase 4 pounds of apples, which was represented by x, and that was where our line intersected the y-axis, and 10 pounds of bananas, and y equaled the number of pounds of bananas, and our y-intercept happened to be 10. So this is your final statement to interpret your intercepts. With $6, you can purchase 4 pounds of apples and 10 pounds of bananas. Now we can begin lesson 2.5, which is learning how to write equations in slope-intercept form. We're going to do this with a graph. So given a graph, we're going to learn how to create a linear equation written in slope-intercept form. So you have 2 steps to this. The first being to use the graph to find the slope and the y-intercept. And then you're going to go ahead and plug those into the slope-intercept equation, which is y equals mx plus b. So let's go ahead and look at this graph for example. Let's first find the slope, or you can also first find the y-intercept if you'd like. So go ahead and look for 2 solid points where you can clearly see their value to find the slope. So I'll go ahead and use this point, which also happens to be the y-intercept. And then I'll use this point, which is the x-intercept. Now slope will be rise over run. So first, identify whether your slope is positive or negative. We can see here that it is positive because it is pointing up to the right. And when we count to our next point, we're actually counting upward for our rise rather than downward. So go ahead and count your units for rise, which is 3. So your slope will equal to 3 over your run, which will be 4 units. So go ahead and plug in 3/4 for m in your equation. And then for b, just find your y-intercept, or where the line crosses the y-axis. And we actually found that earlier, and it's -3. So go ahead and change the plus b to -3. Pretty simple. You're really just using the graph to identify a y-intercept and your slope to plug into your basic slope-intercept equation. So let's take this for example. We're going to write an equation of the line and slope-intercept form. I'm going to first use the graph to find the slope and y-intercept. And then I'm going to plug those into the slope-intercept equation, which is y equals mx plus b. So for the slope, I'll go ahead and first find two solid points where you can clearly distinguish their value. So for example, here it's exactly on this point. And then we can go ahead and do this point, which is exactly there. Now let's go ahead and count our rise over run. Identify if the slope is negative or positive. We can see here that when we're counting our rise in our slope, we're actually counting downward. So we know that it's -1 unit, and then count your run, which will actually be 3. And now you can go ahead and replace m with your slope, -1/3. And now for your second step, go ahead and find your y-intercept, which we actually found right here. And your y-intercept, assuming that this graph is going by ones, would be 2, so +2. So just go ahead and replace plus b with +2. And there's your equation written in slope-intercept form. Go ahead and try these on your own. So write an equation of the line in slope-intercept form given the graph. Once you're ready, let's go ahead and check your solutions. So I'll go ahead and do this graph first. I'm going to first find the slope and y-intercept. So identify two solid points. I'll do this one, and then go ahead and count your rise over run. So in this case, we're counting upward for our rise, so we know that it's positive. Our rise will equal to 1 unit over our run, which will be 2 units to the next point. So our slope will equal to 1/2. And now that you have your slope, identify your y-intercept, which is right here. And our y-intercept happens to be at 4, +4. So if we plug this into y equals mx plus b, we'll get y equals to 1/2 x plus 4. Here's our other graph. We'll go ahead and first find the slope. So we can see here that when we're counting our rise, we're actually counting downward 3 units. So we know that this is negative slope. Go ahead and do this point and then this point right here, 2 solid points. Then count your run, which happens to be 5 units. So we know that our slope is -3/5. And then you can go ahead and identify your y-intercept, which is right here. And that is 1, 2, 3, -3. So your final equation will be y equals -3/5 x minus 3. Okay, let's go ahead and look at a situation like this. We're going to write an equation of the line that passes through the following points 0, 2, and 3, 5. Now recall that you really only need a minimum of 2 points to graph a linear equation. So since we've been using a graph for our previous examples to write an equation in slope-intercept form, we can go ahead and first graph these 2 points. So I'll graph 0, 2 right there, then 3, 5, and then draw a line through them so that we can get a better visualization of our line. Now that you've graphed the line, go ahead and find your slope. We actually already have 2 points that we can use. You can either count it on the graph or you can use your slope equation, which is y2 minus y1 over x2 minus x1. Since we've been counting on the graph for the last few examples, I'll go ahead and use the equation. So remember that you're going to assign each of your ordered pairs a value of 1 or 2. So this will be x1 and y1, then x2, y2, your second order pair. And then you can go ahead and plug this into your equation. So y2 equals to 5 minus y1, which is 2, over x2, which is 3, minus x1, which is 0. And then once you do that, you get 5 minus 2 is 3, over 3 minus 0, which is also 3, and that just reduces to 1. So you know that your slope is 1. In this case, you can also just find the slope on the graph. So this would be 1, 2, 3 units up. We know since we're counting up for our run that this, or our rise, it's going to be positive. And then 1, 2, 3 units for your run. And same thing, you get 1. Now that you've found your slope, take it back to your graph to find your y-intercept. And we see here that it is located right there at 0, 2. So your intercept, your y-intercept is positive 2. Put that in your equation, and you can go ahead and use slope-intercept form, which is y equals mx plus b. Your slope will equal to 1, so you can just put x, or if you'd like to, you could put y equals 1x, plus your y-intercept, which is positive 2, and that's your final equation. You can go ahead and try this on your own if you're feeling confident. If not, we'll go ahead and go over it right now. So this is exactly the same as the previous problem, except we have different points that we're going to be writing an equation for. So I'll go ahead and plot -2, 3, and 0, -1. Then draw a line through them, then find the slope. Once again, either slope equation or the graph. Personally, it's probably easier to use the graph since you've already plotted it. So I'll go ahead and calculate the rise over run by just counting from 2 solid points, which we already happen to have right here and right here. Our rise is actually going downward, so we know that this is a negative slope. That's 1 unit, 2 units, 3 units, 4 units over 1, 2 units. So our rise is -4 over 2, which actually reduces to just -2. So now that you have your slope, go ahead and find your y-intercept, or where your line crosses the y-axis, and that happens to be -1. So now that you have both of your components, you can go ahead and plug this into y equals mx plus b, with m just equal to -2, and your y-intercept being -1. So your final equation will be y equals -2x minus 1. As always, all information regarding tutoring inquiries, additional practice, and lesson requests will be linked down below in the description box. If you're liking my content so far, please make sure to subscribe and like this video. Thank you so much, and I'll see you in the next video.